Today we're going to be talking about solving nonlinear systems. The systems we're going to take a look at are going to be involving lines, parabolas, and circles. Okay, so you should be familiar with all of our forms of the parabolas. And just to remind you for circles, that when you're looking at a circle, the center for a circle is HK, and the radius is R. That's just in case you want to make a quick sketch of the system before you solve. That's all. All right, so when we're looking at nonlinear systems, there are different possibilities for how many solutions there could be. So for example, there could be one solution. And so just try to picture for a minute what one solution might look like. It could be a circle and a line. It could be perhaps two parabolas being tangent at, let's say, their vertex, something like that. It could also be a parabola and a line, as long as that line is just tangent to it in one spot. It could be two circles, again, just having that one point of tangency. So that might be what a system would look like if you were to graph them and have one solution. It is also possible for there to be two solutions. And so again, if you can kind of think for a moment what this might look like, again, you could have, let's say, a circle, and now you could have the line going right through that circle. You would have two intersection points. You could also have a parabola and a line, also two intersection points, right? You could have two circles. Okay, so again, just trying to give you some options here for what things might look like with two solutions. It is also possible that we could have three solutions. So let's take a look at that. Three solutions. Again, try to picture it in your mind before I sketch any here. Three solutions, we could have a circle and a parabola, okay, where it's tangent at one spot but goes through the circle. There's your three intersection points. Do you think it's possible to have four solutions? Think about that for a sec. Let's take a look. Four solutions. It is possible. Think about a circle and a parabola. Here's your circle. And again, the parabola can open up, down, left, or right, but the bottom line is the vertex has to be out of the circle, something like this. So you have 1, 2, 3, 4. Another option might be two parabolas. Maybe an opening sideways parabola and a vertical parabola. 1, 2, 3, 4. Okay, so you could in fact have four solutions. So when you're solving, just be aware you could have one solution, one ordered pair. You could have two ordered pairs, three ordered pairs, four ordered pairs. And also don't forget, it is possible that there is no solution. Okay, remember that a solution to a system is where the graphs intersect each other. So if your graphs are not going to intersect, okay, there's a no solution. You can have a parabola and a line like this, no solution, okay? Now, as you're solving algebraically, what I want you to keep in mind is that we are working with quadratics, okay? And because we're working with quadratics, you want to make sure that as you're working algebraically, all of your solutions must be real. Okay, we are solving over the real number system since these are really graphs, the systems, right? Solving over the real number system. That means if you have to solve a quadratic and you would get a complex solution, there is no solution, okay? So no complex numbers. Think about using the discriminant to help you figure that out if you're not sure if it can be factored, etc. Okay? All right, so let's actually take a look at solving these. And really, probably the best way to solve is going to be taking a look at using either substitution or elimination. And it really does depend on the setup of the problem. As I'm looking here at this first example, I see that both equations are solved for y. So this lends itself right away to substitution. If they're both equal to y, then they are both equal to each other. Okay? Now, it may help in your mind if you have a quick sketch of what this looks like, so you might know how many solutions there are. So for example here, y equals x squared, that's just the parabola through the origin. And then y equals negative x plus 2, the y-intercept is up here, has a negative slope, so I'm thinking there's going to be two solutions. Okay, so that's good to know maybe ahead of time if you can take a quick look. So again, all I did so far was substitute in here, so we have x squared equals negative x plus 2, and now we're just going to solve for x. Since it's a quadratic, I'm going to keep my x squared positive and bring everything else over to the left side. Oh look, I'm going to solve here by factoring, right? So if we take a look to solve by factoring here, what should we do next as we take a look? We'll have x plus 2 and x minus 1 equals 0. So x would equal negative 2 and positive 1. Now, that of course is not our answer, okay? That is just our x values. If you notice, we have two x values because, again, if you look back at our sketch, we have two intersection points. So if we plug x to be negative 2, let's find our solution. I'm just going to use this equation because it's so easy to work with. Y equals x squared. Well, y equals negative 2 squared. Y equals 4. So when x is negative 2, y is 4. Our other value for x was positive 1. Again, same thing here. So y equals positive 1 squared. Y equals 1. So our solution to the system is negative 2, 4, and 1, 1. Two answers. Let's look at another example. Now, looking at this example here, you could do substitution, and what I want you to keep in mind is that you don't just have to substitute in for the linear term, for x or for y. You can substitute in for x squared or y squared. That's fine. But I'm going to look at this and I'm going to think to use elimination because to me I see that I can cancel out the x squareds. So I'm going to keep my first equation as is. And I'm going to multiply my bottom equation here by negative 1 just so that I can add. You know, I like to add. Okay. Now, as we add these together, our x squared will cancel, and I'm left with y squared plus negative y. I can't actually add them together, so I'm just going to rewrite it. 9 plus negative 3 is 6. Again, I have a quadratic. Y squared minus y minus 6 equals 0. Okay, now I kind of wonder here how many different solutions I may have. And what I'm noticing is if I look at my original equations there, it looks like I have a circle whose center is 0, 0 with a radius of 3. And then it also looks like I have a y equals parabola that opens down. Oops, and is up 3 units. So it's up here, and it's going to open down. There's my parabola. Okay, looks like I'm going to have 3 answers. So let's see how that happens. We're going to continue over here by our y squared minus y minus 6 equals 0. And we're going to factor y minus 3 times y plus 2 equals 0. So y equals 3 or negative 2. So now this time I have my y values. So as I plug into my ordered pairs here, I always like to write it in where it belongs so I don't forget whether it was x or y. And I think, I don't know which one you want to plug into. I might plug into this equation here. Okay, so I know that y is 3. So I'm just going to solve this actually for y just because it looks easier to work with it then. So if y is 3, then negative x squared is going to equal 0, which means my x is just going to be 0. So when y is 3, I get one answer for x. I'm going to scoot this up a little bit. Our second ordered pair for, our second value we're going to use is negative 2 for y. Okay. Now I'm just going to erase this so I have some room here, and I'm going to leave this piece here. Okay. So let's see what happens. If we plug in now our y to be negative 2, I can subtract 3. So negative 5 equals negative x squared. X squared equals 5. square root both sides, I'm going to get plus or minus the square root of 5 equals x. So when y is negative 2, I am going to get 2 answers for x. That's these guys here. Okay, so 2 different values for x at symmetric points with the y value being negative 2. So here are our 3 solutions to system number 2. All right, let's take a look at another one. Okay, so here, let's see. For number 3, again, you could take a quick look and see what, if you make a sketch of the graph. I'm going to make a quick sketch here because I notice it's a circle and a line. So I'm just curious how many solutions I'll have. Circle and a line, you could have 1 solution, 2 solutions, or no solutions. Again, I see here that my center for my circle is 0, 0 with a radius of 3. So 3, 3, 3, 3. Here's my circle. Okay. And my line, y equals negative x plus 7. Well, my y-intercept is all the way up here, 3, 4, 5, 6, 7. And I could use my slope of negative 1, but I'm also going to realize, 4, 6, 7, that my x-intercept will be at 7, 0. And if I make this line here, oops, I can tell visually, I can tell that there is no solution. If you choose to graph something like this and graph it accurately, that is enough work to show me that there is in fact no solution. That would be totally fine, okay? I would like to show you what it looks like algebraically when you get a no solution, but we'll save that for another example. Okay, so this one I think is just fine. You can graph it, no problem. That's something I suggest you do. Again, no solution. There's no intersection. Okay, number 4. Here for number 4, again, you can try elimination, you can try substitution. I think I might do substitution, and I think what I might substitute in for is not y, but actually x squared. So I think I'm going to solve this bottom equation here to get the x squared by itself. So I'm going to bring this to the left side. So x squared equals, I'm going to bring the y over here, negative y plus 10. Okay, so here's my x squared that I'm going to substitute in for, right here. So x squared, negative y plus 10. I don't have to square anything because it is x squared, plus y squared equals 16. Now I can simplify. See, I have a quadratic, so I'm going to keep my y squared here, minus y. I'm going to subtract 16 from both sides. Okay. So now, again, I have y minus 3 times y plus 2. This should look familiar. Y equals 3 or negative 2. All right, so now I have a circle and a parabola. Again, you can take a look and see what this may look like. I'm just going to go right to the algebra here just to see what happens. So, when y is 3, I need to know what x is. I'm going to use my bottom equation again. I'm going to use this one. Y equals negative x squared plus 10. So when y is 3, I want to see what x is. I can subtract 10 from both sides. Negative 7 equals, negative x squared. Divide by negative 1. 7 equals x squared. So x equals plus or minus the square root of 7. So I have 2 intersection points right away. And I can do one more here. When y is negative 2, let's see what happens. Negative 2 equals negative x squared plus 10. Subtract 10. Negative 12 equals negative x squared. Divide by negative 1. Square root both sides. So plus or minus the square root of 12 is just 2 root 3. So I have plus or minus 2 root 3. So there are 4 intersection points here. This must mean that the vertex of the parabola is above that circle, and then it opens down into the circle. So you can feel free to write the plus or minus, as long as the y value is the same, or if it was reversed, that'd be okay. But you can't write, if there were 4 answers that were plus or minus 7, let's say, and plus or minus 5 for x and y, you really would have to split those out so we know which positives go with which negatives. But again, when you have just the same y with the plus or minus for the x, it's fine to write it this way. Okay? All right, one more example, and then you guys are off on your own to try. For this last one, Again, you can try elimination or a substitution. I think I'm going to go for substitution here. I see that this is a y and this is y. So I'm going to substitute in to here. Negative 3x squared plus y. So plus negative 4x squared minus 16x minus 13. Continue on. Plus 12x equals 17. I don't like that plus negative 4x squared, so I'm just going to change this. Two signs there. So minus 4x squared. Okay. Now all I have to do is clean this up a little bit. So on the left side here, I have negative 7x squared. And then I have minus 4x. And then I have minus 13 equals 17. I would like my x squared to be positive, so I'm going to move everything to the other side. So I'm going to have positive 7x squared plus 4x, and then plus 30 equals 0. So I do have a quadratic, and so now I have to try to figure out what I'm going to do here. So you could, again, you can choose to solve by graphing. You can choose to solve, see what it looks like. You can try factoring. At first glance, it doesn't really look like factoring is going to be something easy to take a look at. So you know what I'm going to do? I'm just going to find the discriminant. If you guys remember, our discriminant is going to help us figure out whether or not we have some real solutions here. So our discriminant is b squared minus 4ac. Our discriminant is going to be equal to negative 824. That means this would give us two complex solutions. So for our problem here, this means no solution. Okay, remember we're solving this over the real number system. Okay, so that's one way to quickly check, whether or not you could factor it. If you're not sure, you can check the discriminant. You could also put this quadratic in your calculator and see if it intersects with the x-axis. If it doesn't, again, no solution. All right, so that's it for the notes. You guys have the rest of the time to work through your practice packet. Have a good day, guys.